हैं आप सब? कल हमने डिस्कस किया था few concepts of acid and base. In our last lecture, we start a new chapter of 10th class chemistry, acid, base and salt. In the last lecture, we discussed about the definition of acid and base. We discussed about the definition of acid and base. To define acid and base, we already discussed our two concepts. First one is classical concept and second one is Arrhenius concept. Let's start our today's lecture with the third concept, Bronsted-Lowry concept. To overcome the limitations of Arrhenius concept, Bronsted-Lowry again define acid and base. So, according to Bronsted-Lowry concept, acid compounds which donate proton H positive ions, which donate proton, and protons are also known as H positive ions, are known as acids. Clear? Next, according to Bronsted-Lowry concept, base is defined as compounds which accept proton that is H positive ions are known as base. So, definitions are clear. First one, acids which donate proton, base which accepts proton. Now, we are dealing some examples of acid and base both together. So, note it down. Now, we discuss some examples. First example is when hydrochloric acid dissolves in water, it gives H3O positive and Cl negative. Let's observe this reaction very carefully. What is happening here? HCl is the compound which is converted into Cl negative. This HCl converted into Cl negative. Simply from this point we are able to view that HCl is donate proton or release H positive, whereas H2O is converted into H3O positive, means H2O here accept H positive, H2O here accept H positive. So, substances which donate H positive are known as acid and substances which accept H positive ions are known as base. So, in this reaction, hydrochloric acid is acid, acts as acid, and water acts as base. Let's discuss few more examples which helps us to clear which substance is acid and which substance is base according to Bronsted-Lowry concept. Next example is NH3 when dissolves in water. NH3 is known as ammonia. It results into the formation of NH4 positive and OH negative. NH4 positive is known as ammonium ion. NH4 positive is known as ammonium ion. Now observe this reaction. What is happening here? This NH3 takes one H plus and convert it into ammonium ion. So what this ammonia does here? It accepts H positive ion, and the compound which accept H positive ion are known as base. In this reaction, this H2O is converted into OH negative ion. This H2O converted into OH negative ion by simply donate H positive, and the compound which donate H positive are known as acid. Now observe these two reactions collectively. In the first reaction, water acts as base. In the second reaction, water acts as acid. So we have some substances which are capable to act as acid as well as base, and those substances are known as amphiprotic. Those substances are known as amphiprotic substances. Amphiprotic substances which shows substances which are capable to donate and accept the proton are known as amphiprotic compounds. Here, compounds which are capable to donate as well as accept the proton are known as amphiprotic. For example, HClO4 plus H2SO4. HClO4 is known as perchloric acid and H2SO4 is known as sulfuric acid. When these two compounds react with each other, product formed are chlorate ion and H3SO4 ion. So here what happens? HClO4 donate H positive, so this one is acid, and H2SO4 accepts H positive ion, so this one is base. And in normal reactions we know one thing, that H2SO4 plus water, what happens? HSO4 negative plus H3O positive. In this reaction, H2SO4 act as acid. So in these two examples, H2SO4 act as both acid as well as base. So H2SO4 and water, these are few examples of amphiprotic compounds. Clear? Note it down. Next we discuss about the advantages of Bronsted-Lowry concept. Next we discuss about the advantages of Bronsted-Lowry concept. What are the advantages of Bronsted-Lowry concept? The first advantage of Bronsted-Lowry concept is this concept able to explain the reaction between acid and base in non-aqueous solution. Non-aqueous solution. Non-aqueous solution means anything except water. First advantage is this concept able to explain the reaction between acid and base in non-aqueous solution. Non-aqueous solution means anything except water. Second advantage of Bronsted-Lowry concept is able to explain the basic character of NH3, Na2CO3, etc. Able to explain the basic character of few substances or few bases whose characters are not determined with the help of Arrhenius concept. Note them down. The third advantages of this concept, able to explain the nature of ionic species as well. कंपाउंड्स के साथ साथ इस कंसेप्ट ने आयोनिक स्पीसीज के नेचर को भी एक्सप्लेन किया. कैसे? लेट्स डिस्कस वन एग्जांपल. नोट द एडवांटेजेस. Let's discuss one example of the last advantage, that this concept helps to explain the nature. Nature means acidic or basic nature of ionic species as well. Like HCl, when dissolves in water, it forms Cl negative and H3O positive. HCl act as acid here, whereas अगर हम Cl नेगेटिव को देखें, HCl ने क्या किया? H पॉजिटिव को डोनेट किया, जबकि Cl नेगेटिव क्या करना चाहेगा? H पॉजिटिव को एक्सेप्ट करना चाहेगा. सो Cl नेगेटिव इज द conjugate base of HCl. Acid is acid HCl which donate H positive, and Cl negative its conjugate base. Cl negative is its conjugate base. Cl negative wants to or accept the proton, whereas HCl donates the proton. Similarly, in this reaction, water acts as base here, and water converted into H3O positive. Water is base, have tendency to accept H positive ion, but here in this case H3O positive have tendency to donate H positive ion. So base is water, whereas its conjugate acid, the conjugate acid of water is H3O positive. This ions able to donate the proton. This thing is clear? HCl एक एसिड है, वो H पॉजिटिव को डोनेट करना चाहता है. H पॉजिटिव को डोनेट करने के बाद HCl किसमें कन्वर्ट हुआ? Cl नेगेटिव में. This ion act as conjugate base because Cl negative ready to accept the proton. Is this thing is clear to all of you? So Bronsted-Lowry concept able to explain the acidic and basic nature of ions as well. Yeah, note it down. Next we discuss about the limitations of Bronsted-Lowry concept. Limitations of, we discussed about advantages. Now we discuss limitation of Bronsted-Lowry concept. First limitation of this concept is this concept unable to explain the reaction of acidic oxide, that is CO2, SO2, SO3, etc. Reaction of acidic oxide and basic oxide. This concept able to explain the reaction of acid and base in non-aqueous medium, but this concept unable to explain the reaction of acidic oxide and basic oxide, that is calcium oxide, magnesium oxide, etc. Like if calcium oxide reacts with sulfur trioxide, this gives a product CaSO4, but this reaction is not explained with Bronsted-Lowry concept. Second, not able to explain the acidic nature of BF3, AlCl3, etc. The first limitation is not able to explain the reaction between acidic oxide and basic oxide. Second limitation is not able to explain the acidic nature of BF3 and AlCl3. This is all about Bronsted-Lowry concept. Next and our last concept for defining acid and base is Lewis concept. So let's start our last concept. So our last concept is Lewis concept. According to this concept, acids, compounds which have tendency to accept an electron pair are known as acids. Compounds which have tendency to accept an electron pair are known as acids. So what are the properties of these compounds? How we can determine, or on what basis we can predict which substance have tendency to accept electron pair or which substance has not? First property, the compounds must have incomplete octet. The first condition is the compound must have incomplete octet. Incomplete octet of central metal atom. Next one, positively charged ions. Positively charged species act as Lewis acids. La means Lewis acid. Third one is compounds having or central metal having vacant d orbital, or central metal having vacant d orbitals. These are the few conditions for the compounds which acts as Lewis acid. Next, base according to Lewis concept. What are bases? Note these points. Let's start defining base according to Lewis concept. According to Lewis concept, base, compounds which have tendency to donate an electron pair, compounds which have tendency to donate an electron pair are known as base. What are the properties of bases? First is negatively charged species. Negatively charged species acts as Lewis base. Second one, central metal atom have lone pair of electron. Either the compound is negatively charged or the compound have lone pair of electron. These are the two conditions for any substances to act as base. Now let's discuss few examples according to classical concept. Which substance acts as acid or which substance acts as base. Note these definitions. Now let's start discussing examples. Compound which accept electron pair and the compound which donate electron pair are known as Lewis acid and Lewis base. For example, BF3 plus NH3. NH3 have one lone pair. When these two compounds react, they form an adduct BF3 and NH3. For example, this is BF3. As you observed, there are only 6 electrons here, like 2 in this bond, 2 in this bond, 2 in this bond. For completing its octet, boron needs 2 more electrons, and in this case, NH3 has 6 electrons in the form bonded form and 2 electrons in the form of lone pair. Now this lone pair forms a coordinate bond with this boron and forms an adduct, appears like BF3 and ammonia share its lone pair of electron with boron and form coordinate bond. This bond is known as coordinate bond. So now BF3 ready to accept electron pair, Lewis acid, NH3 donate an electron pair, this is Lewis base. This one is Lewis acid and this one is Lewis base. Let us consider one more example. NH3 have lone pair, reacts with H positive ion, positively charged species, act as Lewis acid, lone pair of electron ready to donate, Lewis base. When these two compounds react with each other, they form a species NH4 positive, which involves the formation of coordinate bond. This is all about Lewis concept. The only limitation of Lewis concept is Lewis concept involves the formation of coordinate bond, which is not true always. There is only one limitation of Lewis concept. It always involves the formation of coordinate bond which is not true always. Clear? Because acid-base reactions are quite fast and the formation of coordinate bond is quite slow. This is all about the definition of acid and base. Next we are discussing in our next lecture.